Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Okay, so to get this started, we need to open Unity and start a new project. So we're going to click on the New button in the top right of Unity Editor. And now we need to set a project name. This is going to be named Platformer. Something very simple. As for the location of the project, we're going to put it in your home folder. Okay, whatever that is, doesn't matter if it's on a Mac OS or on a Windows. And then I like to have a projects folder to keep everything nice and organized. This is very important to do right from the beginning if you want to make sure you make big games and you make sure they're all going to be very well organized. As for the rendering mode for the game, we're going to enable 2D. If you enable 2D mode, it doesn't mean you can make and use three-dimensional assets in your game. It's just a presetting that is going to help you import all of your art assets to the game. So we have 2D enabled. I'm going to disable analytics, and now I'm going to click Create Project. So we just sit back a little while, and Unity is going to open. Okay, and after Unity opens, we're going to adjust a few things in our project. It's important for us to build a nice folder structure. So whenever we create new assets of whatever type we want to use, they're all going to be in the right places. Another interesting thing for you to do is when you open Unity, in the top right, you're going to see a layout button. Okay, so to make sure both the editor in this recording and your Unity instance are going to look more or less the same, we're going to click here on layout and we're going to select default. Okay, so we're going to have all the windows, all the default windows, and we make sure everything is going to be looking almost the same. Okay, so now in the project window, you notice that we have our assets folder here. So everything regarding this project is going to be inside this folder. But whenever you add external assets from the Unity Asset Store or the zip file with the game's art, fonts, and sounds from the discourse page, all of these files there are normally added to the root of your project. So that's going to be in your assets folder. So if you just throw your scripts and your images, your animations here at the root folder, things are going to get a bit messy. You're not going to know what has been made by you and what has been made by a third party, okay, something that came from an external environment. So it's very important for us to right click here in the assets folder, select create, then we're going to choose folder, and I'm going to name this project. If this is the first time you're doing this, it might seem like this is unnecessary because, well, we are working with our project. But whenever you add other assets, they're going to be here in the root as well. So if you add, for example, a first-person shooter package, it's going to be here. If you add a particle effect package, it's going to be here. So everything is going to have its own folder. And some packages, they don't even have folders. They just they just add lots of folders here, like scripts, animations, scenes. So if you make this project folder, you're going to ensure that everything you do is going to be here. Okay, and in this project folder, it's interesting to create a few other folders. So I'm going to create an animations folder, animations. Okay, we're going to make a scene folder, scenes in plural. I'm going to make a scripts folder. Okay, and for now, I think this might be enough. Actually, one more. Let's create another folder called prefabs. Okay, we're going to have these 4 folders for now. And since we're talking about project organization, making sure everything is going to be tidy, it's also interesting to do something here in the hierarchy. So whenever you make a new game, and whenever beginners make their first games, they tend to just add things to the hierarchy like this. Okay, we have the camera, Then we're going to add a player here. Okay, I'm just adding these as an example. Don't worry about it. I'm going to add a cube. Then I'm going to add things. And you keep adding things to the hierarchy, but there's actually no hierarchy in here. Okay, we just have a bunch of objects being added to the scene hierarchy. So one thing that I really like to do is to create an empty game object here. So I'm going to right click, choose create empty, and I'm going to rename this game object to scene manager. Okay, make sure its position is 0, 0, 0, rotation as well, and scale set to 1. Okay, and I'm going to get the camera that already came with this scene, and I'm going to drag and drop it inside the scene manager. So why are we doing this? For a few reasons. First of all, the scene manager, this game object, is going to have its own script, and it's going to take care of lots of things in the game. It's going to keep track of the score. It might control the camera if you want. It might kill the player. So the scene manager is kind of the thing that oversees how the entire game is working. Okay, so this is something very important to have, because this is going to force you to think on better ways to communicate between an object and the other. If you just throw things at random in the hierarchy, you might have a messy code. Okay, for example, the scene manager is going to know who the player is, but the player doesn't need to know who the scene manager is. If you are a beginner programmer, that might seem a little difficult to understand right now, but as we make the game, I'm going to keep going back and mentioning the importance of making a good hierarchy so your game can be easily expanded. Okay, so we have the scene manager here, and of course we have our own scene here in Unity. That's where everything is going to happen, where all your objects are going to be placed. So right now the scene is not saved. It's just saying untitled, and it has this asterisk mark because it's not been saved. So what we're going to do here is go to File, hit Save Scene, or just hit Ctrl S or Command S. We're going to Platform a folder, then Assets, Project, Scenes, and inside the Scenes folder, I'm going to name this Game. Okay, Save as Game. So I just hit the Save button. And after you do this, if you go to the scenes folder, your scene is going to be here nice and easy. Okay, so whenever we do any changes to the scene, it's important for us to hit Ctrl S or Command S to save the scene and also save the project. If you use this shortcut, this is called automatically, but whenever you finish a lesson, whenever you make sure everything is working, remember to save your scene and save your project so you don't lose any work. Okay, so whenever you have all of these things ready, we're going to move on to the next lesson where we're going to work with our player. The player is one of the most important elements in this game, and in every game to be honest, because it's going to be the main point of contact between the player and the game itself. It's the thing that you control, and you can interact with several game elements and collect coins and maybe weapons, jump at enemies, and reach the end of the game. So it's interesting for us to start with the player. So what we're going to do in the scene manager is to right click here. We're going to choose Create Empty to make an empty game object. If you select this moving tool here, you're going to see where the game object is located in our scene. Okay, it's in the same position of the camera, but you can click on this square and move it to another position. The important thing is we're going to make sure that since this is a two-dimensional game, for almost all elements, we want its Z position, this is the depth position, to be 0, because this is a two-dimensional game. If you were to disable this 2D button here in the scene window, you would see the depth here in a three-dimensional mode. But let's make sure that at least almost all times we're going to be in two-dimensional mode. Okay, so I'm going to rename this game object to player. Okay, and I'm going to do some other things here. Inside the player, we're going to select it, right click, choose create empty, and rename this game object as container. Okay, and after we add this container, which I'm going to explain soon, we're going to right click, select 2D object, and then sprite. So we have this new sprite game object here. I'm going to select the new sprite, rename it to just sprite, And well, we need to see something, so we're going to be able to control our player. So to see something here, we actually need an image, and we don't have any created by us right now. These are going to be added later, but the goal here is to show you that you can make entire games by just using very simple sprites, very simple blocks, and then later just replace with the art that you create or you download from whatever source. So here in the sprite field of the sprite renderer component, we're going to click on this circle to the right, and you're going to see that there are a few options here. These are some default elements provided by Unity. Okay, you could use any of these that you want. I'm going to choose this one, UI sprite. If you have a white sprite or a black one, whatever color you have, you can just drag them into your project folder in your game and use them here, but we can use something already provided by Unity. So let's use UI sprite. Okay. Once you double click, you're going to see a very small sprite here. So what we can do is just scale it so it's going to be a bit more easier to see. So 10 on X, 10 on Y, and 10 on Z. Even though we're not using the Z one, let's just make things uniform. Okay, so this is the sprite that we have. And if you want to understand how this is looking like in the actual game, you can click on the game window right here. Okay, so if you were to play the game, it would look exactly like this. This entire blue area is the camera, is what the player can see, and this is our player. Okay, so you might be asking, hey, couldn't we have just added a sprite and named it player instead of making this entire hierarchy? Well, yes, we could have done this, but the interesting thing about having a player game object, a container, and a sprite one is, if you want to change an image, you just need to change this sprite game object. If you want to add several other visual assets and effects and particle systems, you can just put all of them inside the container game object, so everyone would be here. Okay, if you want to add another sprite, if you want to add a particle system, for example, all of these things would be inside this container. And why do we do this? Since this is a two-dimensional game, sometimes we want to do a few changes in how the game is looking like, okay, on the visuals here. So for example, we are going to have animations of the player walking to the right. If you want to make them walk to the left, you don't have to export dozens of images of the player looking to the left. You can just get this container that you see here and change its horizontal scale from 1 to -1, and it's going to automatically flip to the left. Okay, you could do this directly with the sprite here, but if you have other elements, it would take a little bit more work. So to simplify things, we have this container game object. It's essential for you to understand this because it's kind of the main reason we have hierarchy in making games. Okay, you put things inside a box, inside a folder, inside a game object in Unity's case, and if you change how this game object behaves, everyone inside the container is going to change as well. So if you rotate the container like this, for example, if you rotate on the z-axis, all of the other elements are going to rotate as well. So you just worry about the container and not about the other things inside the container. Okay, but well, the container could be the player, right? Why do we have a player game object? Couldn't be just this one be just a player? Well, yes, it could, but this one is, you would understand a little bit better if you had more experience with animations. But sometimes animations in Unity are a bit difficult to deal with if you want to do some effects. So the good thing here is the player is going to be responsible for the game logic. Okay, so here we're going to have a player script, we're going to have the physics, we're going to have the collision boxes, whatever you want to add here that is regarding the logic. The container is going to be the visuals, and the sprite is going to be all the visual elements. This is a good idea, a way to understand this hierarchy. And we need to make sure that at least for almost all elements we use this kind of hierarchy. Okay, the name of the element, container, and its visual elements inside the container. Okay, so now that we did this with the player, we need to add a few things, and the first one is going to be a player script. Okay, because if you just press play, if you want to simulate your game right now by pressing play and looking at the game, nothing is going to happen because we didn't add any behavior to the player. It's just a square appear around the rectangle with a position, and it basically does nothing. Okay, so we need to add a logic here. So to do this, we need to write our own code for moving the player. We're going to the scripts folder, we're going to right click, choose create, then C# script, and I'm going to rename this to simply player. After you hit enter to typing the name, you're going to wait a little bit for the code to be ready by looking at that loading circle, and after this is done, we are good to go. So now we're going to select the player game object. Okay, make sure you select this one, not the other ones. If you don't want to confuse yourself, you can just collapse this hierarchy of the player. And to attach this script to the player, you can just drag and drop it here, or if you have the player game object selected, you can just drag and drop it here in the inspector. So you add the player script as a component. Okay, components are the things that are going to be used in this game object. The player now has a transform component, which is going to change where it's going to be positioned and what its location, rotation, scale. And we now have another component that's the player one. So we're going to make things like move the player and make them jump. The player is going to need other things, okay? Because if you press play now, well, the player doesn't behave, of course, but the thing that we would expect to happen is for the player to fall. Okay, it's a platformer game, so we need a minimum amount of physics working here. That means gravity needs to work, the player needs to fall. And we don't have to code gravity, we don't have to code physics, things like colliding with elements, hitting elements. Okay, these things are already built in Unity. So to use them, you can just select the player game object, click add component, and here we're going to search for rigid body, but something important as well. Rigid body has two different components. We have rigid body and rigid body 2D. As we are dealing with two-dimensional elements, we need to make sure that we're always going to use the two-dimensional versions of the components if that version exists. So we're going to select rigid body 2D. Okay, we click here to add it. Okay, and you're going to see that this component has lots of settings here, like body type, what's going to be its mass, its angular drag, its gravity scale. Okay, so we're going to use this the way it is right now, and as we think it's necessary, we're going to add a few other things like constraints. Okay, we're going to see this soon. And now that we have a rigid body, we still need to tell other things to Unity. Okay, so this is the player, but Unity doesn't have any information of the collision area of the player. Okay, even though we have an image here, since we have a lot of freedom, since we can have different shapes, as many shapes as we want, Unity still doesn't understand that we need to use this area to be used as a collision area. So Unity would not understand where the player is going to be stepping on, for example. So to do this, we need a collider. We're going to click on add component. We're going to type collider here, and a good one for this game is going to be the Capsule Collider 2D. Okay, if you click, you're going to see a tiny capsule shape, this green one, and we can resize that capsule shape so it's going to be fitting this image better. So we have the size on X and on Y. Okay, X is a half and Y is 1. I'm going to increase Y to 1.45 and X to 1.45 as well. Okay, it has a little bit of a circle shape, but it's what we're going to use for now. Okay, you can change this later to another different shape, but this one is going to be good enough right now. Okay, whenever we add the art for the player, when the player is going to be taller, it's going to be looking more like this. But for now, we're going to make it look like this, a little bit like a circle. Okay, so good. We have added a rigid body, a capsule collider, and if we press play at this point, we should see the player in the screen, and the player is going to fall. Okay, so good. We have physics working. We have the game behaving a little bit like we want it to do. Okay, but the thing is, if we press play to simulate the game, the player is just going to fall down, and we are never going to see the player again. So it's important for us to add a floor here, just somewhere where the player can stand. So in the scene manager, I'm going to right click, choose create empty, rename this game object here to level. We make sure it's in the position 0, 0, 0, rotation 0, scale 1. Okay, it should be by default. And on level, we're going to right click, choose create empty. I'm going to rename this game object as floor. Okay, and I'm going to move this floor down to this position here. We're going to add some art to this floor as well, something very basic. So we right click, choose 2D object, sprite. Okay, no need to add containers to more visual elements like the floor. I'm going to select this new sprite here, click here, and choose this one, UI sprite as well. Okay, I'm going to change the scale in X for this sprite to 100. Actually, let's use 1000 here, and on Y we can use 10, like this. Okay. Now I'm going to pick the floor, move it down a little bit, just so it's going to be fitting the camera area like this. And now we need to add a collider to this floor. So we click on Add Component. We're going to search for Box Collider 2D. We're not going to use Capsule for this one. So I'm going to click here on Box Collider 2D. We need to change the size a little bit. So the size on Y is going to be 1.3 should be enough. And the size on X, that could be something very large, just for now. We're going to use 100 on X. Okay, so it's a bit shorter than the sprite, but we don't need to do anything super complicated right now. Okay, we just want to make a floor where the player can stand. Okay, so I'm going to collapse the floor and the level for now. If you want to change the color of the floor, by the way, to make things easier to see, you can just click here at the floor and choose the orange color, for example, like this. You just select the floor, go to the sprite render component, click here on this colored rectangle, and you pick whatever color you want here. Okay, just pick one that looks good, and then select it here by dragging this circle around. Okay, so if you look at the game window, it's going to look like this. And if we press play, we have our player here. The gravity is going to be applied, but the player now is going to fall on this floor, which is perfect. It's exactly what we wanted. Right now, we didn't write a single line of code, but we were able to make gravity work and understand a little bit on how the colliders work. Notice that you can change things while the game is playing to test a few things and understand a bit better how they work. So while the game is running, I can even select the player here and change the size of the Capsule Collider. If I wanted it to be 2, for example, notice that the cube is now floating. Okay, if you change the size of the collider, you're going to notice that Unity is not using this white block as a collision area. It's using the collider that we added. It's this green invisible capsule. Okay, you can't see it in the game, but you see it in this scene. Okay, as a developer, it's important for you to see this. And if you move back to 1.45, the block is going to fall back to the floor. Okay, but remember, every change you do while the game is playing is going to be discarded because it's assuming you are testing things. So I'm going to stop the scene right now. Okay, we have something nice set here. I'm going to rename the floor's sprite to just sprite as well. Okay, so good. And now at this point, we need to write some logic for our player. The player needs two basic things to work. We need to make the player walk, okay, to the left and to the right, and we need to make the player jump as well. These are the two basic things a player must have. Okay, so to do this, we need to save our scene first. Okay, so File, Save Scene, File, Save Project, and we're going to move on to the next lesson to code our player. To work on the player's code, we need to work with the player's script. So we go to the project window, then Assets, Project, Scripts, and the player script that we created before. Okay, and remember, the player must have the player script attached here as a component for all the code that we write in the in MonoDevelop to work. Okay, so it's going to open an external software, MonoDevelop. It's something that already comes bundled with Unity, and it works pretty well. Okay, so we need to understand a few things first. Notice that the code already came with lots of things already written for us. It might sound confusing if you never work with C# or with code at all, but it's actually super simple. Okay, these three lines here, these using lines, they're just importing namespaces to the player script. It's kind of preloading a few resources for you so you can code, you can make all your code in an easier way. We don't have to reinvent the wheel if we have things already set for us. So it's important to have these three lines already added so we can use some classes, some functionality that is required for the player to work. Then here we have the definition of the player's class. Okay, everything that changes how the player is going to behave is going to be inside these two curly braces. And inside here we can have variables and we can have methods. Okay, and methods like the start one and the update one are going to be a collection of instructions that are going to change how this player is going to behave. Okay, so the start method is used for whenever the player game object is loaded, okay, and the component is loaded as well. So you can use this to preload a few things or find some things. And the update method is one of the most important ones because this is going to be called every frame. So every time your game loads in your mobile phone or in your computer, in your video game, for example, every frame is executed, the update method is going to be called. So if you have a game that runs at 60 frames per second, the update method is going to be called 60 times a second. Okay, so imagine like the update method is something that's called all the time. So I mentioned that inside the class we have methods and variables, but I just showed you these two methods. There are no preloaded variables here, but we can make our own. Okay, if you just come here and type public float speed, you already made a variable. Okay, the name of this variable is speed. Okay, so it's an easy name for us to just fetch or save something somewhere in the available memory for us. Float is to say that this speed variable is going to be a floating point number. So it's a number with a decimal portion. Okay, it's not just 1, 2, and 3. It could be 1.5, 2.25, 3.76, whatever number you want. There are lots of options for numbers when you use a floating point number. And it's public because this can be seen, okay, this can be accessed from other classes and even in the Unity editor. So if you save the script right now, if you go to Unity and you wait for the code to compile, if you look at the player component, you're going to see that the speed variable is kind of magically going to appear here in the editor. Okay, so even though in the script of the player we didn't assign it to be something like 2f or 3.5, for example, we are going to set it actually here in the editor. This is good because it's going to be easier for you to test things. Okay, if you want to make the player to move faster, you can just come here and type whatever number you want. 3, for example. If you play the game and you feel like the player is moving very slowly, you can just increase it and test it without having to go back to the code and do something. Okay, because whatever you do here, if you change something, okay, for example, if I take off this line and I save the script and I go to Unity, the code needs to recompile again. So you have to wait for a few seconds, depending on how quick your computer is, and that's going to be taking a lot of time. Okay, if you can do something that can be public here, so you can change it in the editor, it's going to be much better. Okay, and just to organize things a little bit more, just to add a few good practices here since we are beginning, it's interesting for us to add a few headers here. Okay, so I'm going to open and close these braces. I'm going to type header, and between parentheses I'm going to add a name. So I'm going to name this movement. This is kind of a way to tell Unity that every variable under this header is going to be about movement. Remember, this is actually not necessary, but if you save this and you look at Unity, you're going to have a nice label here showing the group of variables that you're working with. Okay, so we have now the text movement. It does nothing, you can change this, but now that we're doing this, every variable regarding movement that we add is going to be under this nice label. So for example, if you want to add another variable here for jumping, you can add public float jumping speed, okay? And this one can be walking speed, for example. If you save this, if you go to Unity and you wait for it to load, then you're going to see walking speed and jumping speed, okay? Like this. And you're going to even see that Unity prettifies this text by adding a space here, okay? Because we started with a lowercase w. When we go for an uppercase letter, it's going to automatically add a space here. Okay, so it's looking very well. I'm going to change walking speed to 3 and jumping speed to, let's see, 5 should look good. Okay, let's keep these two variables. Okay, now I'm going to save here, save the scene, save the project. And of course, we can't just make the player walk by just adding these two variables. We actually have to code something in the player. And to make the player walk, there are a few things that you can do. Okay, you can listen to specific keys in your keyboard, or you can use Unity's built-in input system. So if you go to Edit here, if you go to Project Settings and then Input, you're going to see that we're going to have this axis area. So if you click here, it's going to open lots of different options. So we have an axis called horizontal. If you expand this, you're going to see a few things, like the name of the axis, and the important thing here is the buttons that are used for this axis. So we have horizontal, we have left, we have right, okay, we have, this is the left key, the right key, and we also have some alternate buttons. We have the A key and the D key. We also have a few things about the sensitivity of this axis, but it's not necessary to look at right now. Okay, so that's good. We're going to use the horizontal axis to make the player move to the left and right. We also have another axis here called jump. Okay, so it's just the space button. Okay, and that means that if you press space, the player is going to jump. Okay, the good thing about using this system is because this supports multiple inputs. Okay, so here we are supporting the keyboard, but if you look here, you're also going to support the joysticks. Okay, so if you were to export this game to PlayStation 4 to or Xbox One, it's already going to support joysticks built in. Okay, even on Android devices, if you connect an external joypad, it's going to work as well because it's already supported here. So it's something interesting for you to work with. Okay, so we need to connect our player with the horizontal and the jump axis. How are we supposed to do this? So in the player, it's actually pretty simple work, but we still need one thing for the player. We need to access the player's rigid body component because this is the thing that is going to make the player move. To do this, we need to save a reference to that component, okay? So I'm going to add a variable here, but instead of adding it under a header, I'm just going to press enter twice to go to this line here, and I'm going to type private rigid body 2D, and I'm going to name this player rigid body. Okay, it's private, so it's not going to be accessed by anyone. Okay, its name is player rigid body, and right now player rigid body is just null. Okay, it's not storing anything. So we need to save something here in this player rigid body, and the start method is the best candidate for this operation. So here we're going to type player rigid body is going to be, and then how do we access the rigid body of the player's game object? So here we're going to type game object and then dot get component. It's a method call, and we need to specify what component we want to get. What is the type of the class that we want to get? So I'm going to open and close these two characters, the lesser than and greater than signs, and here I'm going to put rigid body 2D. Since this is a method call, we need to open and close parentheses, and since we are finished with this line, I'm just going to add a semicolon. Okay, so we are in the player class. We access the game object, so then we can access the rigid body component. If you look at Unity, it would look like this. We are in the player class, the player script. We're going to access the game object, and then we're going to search for the rigid body. So we search here, here, and here. Okay, since we found this rigid body 2D, this is what we're going to return. So that component is going to now be saved here in this player rigid body. Okay? And now, how do we make the player move? I'm going to add a comment here just to make things easier to read with human text. So you add 2 slashes like this. And I'm going to add, make the player move horizontally. Okay, so this is quite easy. If you type player rigid body and then type dot velocity, you're able to change the velocity of the player, okay, both horizontally and vertically. So to change the velocity, you can just change the x value like this. You actually need to save another object in this velocity. Velocity is a vector 2. Okay, so you can save an x and y values. So I'm going to type here new vector 2. Okay, we need to pass something in the x value and in the y value. So I'm just going to type x and y like this. Okay, I'm also going to put these 2 characters in a new line, so this is going to be easier to read. Okay, let's go for the y value. We're just talking about the horizontal movement here, so we don't want to change whatever is set in the y value. Some people might think you just have to add 0 here, but the issue about adding 0 is because the player is never going to fall again. It's just going to stand still. Okay, so this is not what you want to do. If you don't want the y velocity to change, you're going to just type here player rigid body dot velocity dot y. Okay, you are repeating whatever is saved here. All right, and as for the x-axis, this is where the magic is going to happen. We want to access the horizontal axis in our input system. So I'm going to type input dot get axis, and between parentheses, we're going to add the string horizontal. Okay, now one important thing. This get axis here is going to return a number between -1f and 1f, okay? 1f means the horizontal axis is completely positive, okay? And -1 means that the axis is completely negative. And sometimes you might get some values in between. For example, if you're playing with a joystick, you don't need to move your joystick all the way to the right. If you move it just a little bit to the right, you're going to make the player move slowly, for example. Okay, and this is good to have when we add some sensitivity. We're going to see a little bit of acceleration in the player, so it's something nice to have. Okay, so we're going to put input.getAxis. Then we get the horizontal axis, and I'm going to multiply this by movement, actually walking speed. Okay, so when we do this, we're going to save our game here. We go to Unity, we're going to wait for the code to compile, and after this is done, we're going to press play to see how this is going to look like. Okay, so we have our player here. If I press the right key, the player is going to move to the right. It's going to roll to the right. I'm going to change this soon. And if I press the right arrow key, it moves to the left. If I release it, you notice that there's a little bit of deceleration. And if I press the key, it's going to accelerate because the axis goes from 0 to -1, and there's a little bit of kind of gravity being applied here, so we have an acceleration. So this is good to have because we have some smooth movement here. Okay, if you want to make the player move faster, you can just come here and test other values. If you wanted to walk with a value of 5, you can just change here while the game is running, and you can press the keys. So maybe it's a better speed here. Okay, 5. And if you want to use 5 as the walking speed, remember you have to stop the game from running, go here in movement, and change walking speed to 5. Okay, so a few things. If you don't want the player to roll like it is doing right now, you have to freeze the player's rotation. So you have to select the player game object. Okay, you're going to the rigid body 2D, and you're going to notice that there's a constraints field here. If you expand it, there are some options. You can freeze the player's position, but we don't want to do this because the player moves both horizontally and vertically. But we do want to freeze the player's rotation. Okay, we don't want the player to rotate. We're going to simplify things to make the game easier to develop. Okay, we press play. Now I'm going to press to the right, the player walks to the right, and then left. I'm pressing the arrow keys, but remember, you also have alternate buttons. So you can use D and A as well to make this movement. Okay, so we successfully made the player move horizontally, but we also have to work with the player's jumping logic. I'm going to just start a little bit of this logic, but you would notice that we have to change a few things. Okay, so first of all, let's save the script. Then I'm going to the player. Okay, and in the update method, I'm going to type here, make the player jump. Okay, we're going to do something almost identical as this block of code that we have here. Okay, so I'm going to type player rigid body dot velocity, and that's going to be a new vector 2. Okay, since we're dealing with the y-axis now, the vertical axis, we don't want to change whatever is stored horizontally. So here I'm going to type the opposite of what we did in the beginning. Player rigid body dot velocity dot x. Okay, and as for the value on y, we're going to use the jump axis. I'm going to put input dot get axis, and between parentheses we're going to add here jump, this string, okay, multiplied by jumping speed. Okay, so we're going to save this. We're going to Unity, we wait for the code to compile, and after this is complete, we're going to press the play button. Okay, so we're going to have the player here. It's going to fall. Notice that we have an issue now here. Notice that the player falls really slowly to the floor. Okay, if you press play again, if you want to see it again, you're going to see that the player is falling really slowly. And this is because we have a little bit of an issue here. When an axis is not being used, the value stored here is going to be 0. So on every frame, it's going to kind of compete with gravity to make the player standing still, to make the player stand still. Okay, so we shouldn't use the jump axis the same way we use the horizontal axis, because what we need to check with the jump axis is, if the jump axis stores a value greater than 0, it means that we pressed the jump key. Okay, so here in the player jump, specifically for this jumping logic, we're going to type if input.getAxis, and then the axis jump string we added here as a parameter of the getAxis method. If this is greater than 0, then we're going to do this. Okay, and instead of multiplying the axis by jumping speed, we can just add jumping speed. So we actually need to ask our code if a situation is happening, if the jump key is being pressed, which is the same thing as looking if the axis stores a value greater than 0. And then only if this happens, we are going to apply our jumping speed. So let's try that again. I'm going to save, go to Unity, wait for the code to be ready. We press the play button. So the player is going to be falling, and then it's going to stabilize here in the floor. Okay, we can move the player as before. And if I press jump, the player is going to do a little jump. Okay, if you want to make the gravity a little bit stronger, and this is a nice tip to know, you can select the player. Okay, I'm going to change the jumping speed to 10, and in the rigid body, you can change the gravity scale to 2. Okay, so now if you jump, it's going to look like this. Okay, it's a little bit stronger. Okay, even though the player is reaching the same height as before, the gravity is stronger, so it's going to make the player fall faster. Okay, so I'm going to stop here, change the jumping speed to 10, and the gravity scale to 2. So this is going to be saved. Okay, so let's press play again, try this one more time. All right, pressing play, good. We have the behavior as before, but there is a problem. If I press jump mid-air, the player jumps again. Okay, that's not a behavior that we want to happen. And if you hold the space button, the player is going to just move up forever. Okay, so it's actually looking more like a jetpack than a jumping logic, and that's not what we want to do. It's a little bit of a tricky thing that we have to change to make the player jump just once, and then the player would only be able to jump again once they touch the floor. Okay, this is the adjustment that we're going to see in the next video. So right now, we're going to save our scene, save our project, and move on to the next lesson. So what we need to do here is something that might seem a little bit difficult to see, okay, to understand, but once you get it, it's going to be fine. Okay, so right now, our player can jump mid-air, and actually fly. If we just hold down the space button, it's going to move up indefinitely. But what we want to do is, this logic should only be executed if the player is standing somewhere. Okay, if the player is standing on the floor or on a moving platform, even on an enemy, for example, whatever you want, just make sure the player is standing somewhere. So what we want to do in code is, there are several solutions for this. You could add a little timer in the player, so you only allow the player to jump every 1 second, for example, but that's not something really good. Okay, it's very easy to make a mistake here. If the player does longer jumps, the player might jump mid-air, so it's something that doesn't work correctly. What you need to do in code is, we're going to be here in the player and we're going to look down. Okay, imagine we are in the center of the player and we're going to kind of shoot a ray, okay, kind of a laser. So we're going to look at the point just below the player, and if there's anything just below the player, then we are authorized to perform a jump. Okay, that's what we want to do. Look under the player. If something is here under the player, then and only then the player can jump. Okay, so what we want to do is a ray cast. We shoot a ray towards a certain place. We're going to identify if anything is in that place. In that case, we're going to check if there is a floor there. And if there is a floor there, we're going to make the player jump. Okay, so how do we do a ray cast? We need to type physics2d dot raycast. Okay, and the raycast method, if you open parentheses, you're going to see all the available versions of this method. Notice that there is one of 7 here. So you need to determine the origin of a raycast and the direction in this version. In this one, we have origin, direction, and distance, which is a great one. And there's another one here that's a bit better. It's a little more aligned with what we want. And whenever we call this raycast here, we need to know if we hit something. Okay, so if you use it like, let's see, what is the correct version? This one is an int. This one should be the correct one. Okay, so we have a raycast method here. Okay, it's a public method, so that means we can use it normally. It's a static method, which means we don't need an instance of this class to exist. And the good thing about this raycast method call is it's going to return to us a raycast hit 2D game object. Okay, so if we hit something, this is going to contain something here. Okay, so if you call this method with an origin, a direction, and a distance, we will definitely know if we hit something. So what we want to do here is physics2d.raycast. The origin is going to be the center of the player. So here we're just going to type transform.position. The second parameter of this method is going to be the direction. As we are jumping up, we want to cast this raycast down. Okay, so a simple way to do this is just typing vector2.down. Okay, and as for the third parameter, we're going to pass the distance of the player. Okay, the distance below the player to be used to identify if we are stepping somewhere. Okay, so a good way to do this is to get the capsule collider of the player here and get its height. Okay, and we're going to add just a little bit more after this height here, and that's going to be used as the player's floor. Okay, so we're going to save the player's height here. Okay, in the beginning of the game, I'm going to type private float height, and in the start method, we're going to say that height is going to be game object dot get component of type capsule collider 2D dot size dot y. Okay, this is what we need to use to get the vertical value of the player. Okay, like this, the vertical size of the capsule collider 2D. All right, and here when we want to cast the raycast, the distance that we want to do is height. Okay, and one important note: height is all of this, okay? But since we are casting from the middle of the player, we're going to use height divided by 2, okay? So height divided by 2, I'm going to put this between parentheses, And I'm going to add just a little bit more, so it's going to look down. So plus 0.1f. This should be good enough, okay? And then we close parentheses and we add a semicolon. So this is going to return a raycast 2D game object, okay? So we're going to store this in a temporary variable inside this method. So raycast hit 2D, which I'm going to call hit, and then I'm going to assign all of this here, okay? And then we're going to print in the console to see if this is working correctly. I'm going to add a debug.log to print in the game console. And between parentheses, I'm going to add hit dot, let's see, what are the options here, dot collider dot name. So we're going to print the collider game object name, okay? So I'm going to save this. And actually, before we do this, we're going to see this problem going on here. I'm going to save, go to Unity. We're going to wait for the code to compile. I'm going to select the console window where we're going to see the printing messages. And I'm going to press play. Notice what's going to happen here. When we press play, right in the beginning, we just see the player message, okay? Our collider is hitting our player, but we don't want the player to be a result of this collider here, okay? Because if the player collides with itself, it shouldn't be allowed to jump. We actually need to unconsider the player here and just consider the floor, okay? So to do this, we need to change this a little bit. Okay, I'm going to stop this scene, and in the next video we're going to learn how to perform this adjustment. At this moment we are using the raycast method of Physics 2D, but the issue we have is when we use the raycast we are already returning the player. So the thing about the raycast method call is it's going to return the first instance that's hit here. Since the raycast comes from inside the player and it moves down, it's going to hit the player itself. So we have a few options. One of them is to actually use raycast all to return all the elements that are going to be in the way of the raycast, not just the first one. Or we can make this raycast come from below the player, which should be something that's pretty okay to do. Okay, so instead of using transform.position here, we're going to type new vector 2, should be fine. The x position is going to be transform.position.x. Then the y position, transform.position.y. And then we're going to add here a minus height divided by 2. Okay, should look like this. So the raycast is going to come from the bottom of the player. We're going to see if we're going to need a little bit more to add a little bit of this. Okay, so it's going to come from below the player to the down direction, and it's going to go just a little bit below the player. So let's save this script, go to Unity. We're going to wait for the code to compile, and after this is done, we're going to press the play button here. Okay, so we're going to press play. The game is going to load in the console, but we still see the player being returned here. So I'm going to add a little bit. Decrease a little bit more down. Okay, so we have player's vertical position minus height divided by 2, and then I'm going to add a minus 0.1f, and here let's use 0.2f. Okay, we save again, I go to Unity, wait for the code, and after this is complete we're going to press play. Okay, so when we press play now, the player is going to be here, and something interesting happened. Notice that in the beginning we had an error. Okay, it's saying here no reference exception. And if you want to understand what's happening, if you click on this error, you're going to see that it's going to point to line 28, and it says object reference not set to an instance of an object. If you look at line 28 here, that's happening because when the player is in the middle of the game, when it's mid-air, it's not going to be colliding with anything, so hit is going to be null. Whenever you try to access something in a null object, well, since the object doesn't exist, it's going to throw an error to you. Okay, so that's why in the beginning we have an error, and we shouldn't allow this to happen. Once the player falls, it's going to print the name floor. If we jump, we see the error again, like this, and when the player falls, we see floor. So we're almost done with this. What we have to do is, Instead of printing this, I'm just going to add this hit object here. And to allow the player to jump, we need to verify if hit, okay, if the object that we hit is different than null. So we can just come here in this if line, and we're going to add if hit is different than null, and we are trying to make the player jump. Okay, so if these two conditions are true, then and only then we're going to make the player jump. Okay, I'm going to move this comment up here and put these two lines closer. Okay, if you want to make this a little more precise, we can, instead of using 0.1 here, we can use 0.01 and here 0.02. So I'm going to save this script, go to Unity. We're going to wait for everything to be ready, and we're going to try this one more time. Okay, so I'm going to press the play button. And okay, we have our player here. I'm going to walk to the left, to the right. If we press space, the player jumps. Okay, we still see the player jumping mid-air, so we still need to adjust this. But the thing is, we need to verify if we are looking at something that's not null. Okay, and that's the only situation the player should be allowed to jump. Okay, so there's something here missing. So I'm going to put here a debug.log, and then hit is different than null. Okay, so I'm going to save this. Let's go to Unity. Probably that little thing that we added here, since we reduced it to 0.1, wasn't enough to make the raycast not touch the player. So we should use the value we had before. Okay, it's always returning true. So yeah, we need bigger numbers. So let's use 0.1 here and 0.2 here. Okay, we're going to save this, go to Unity, wait for everything to be ready, and we press play. Okay, once this is done, in the beginning it's going to say true because we are touching the floor. If we jump, it's still happening, so something else is missing here, so let's check that. We're going to print hit, then dot collider dot name. Probably the player is hitting back here. Let's see if that's the case. Okay, we press play, wait a little bit. And yeah, in the beginning it's still saying null. So let's see what's going on. Notice that if I try now, it's working. Okay, it's only the player only jumps if it's touching the floor. So let's check here. So the thing is, it's a little bit tricky here. The thing is, hit.collider is the thing that gets null. Okay, hit is always going to return something different than null. So instead of checking if hit is different than null, we have to check if hit.collider is different than null. Okay, if no colliders exist, it means we've collided with nothing, then we can't jump. If we collide with something, then we are allowed to jump. Okay, so let's return to the small numbers here, 0.01, 0.02, and let's try that one more time. We save our script, move back to Unity, we press the play button here, and let's try jumping mid-air again. Okay, we have the player, I'm pressing space, the player jumps, and the player only jumps again when they touch the floor. Okay, I'm holding down space and the player jumps when it's on the floor. Okay, floor, space, only jumps when it hits the floor. Okay, so it's important for you to see these little mistakes that happen here, these little problems that happen here, because some objects behave different than others. Okay, in the case of raycast hit 2D, hit is going to exist, but collider not always exist. Okay, and reviewing the logic is, we did a raycast. We came to the player here, we are in the center, we moved the origin of the raycast to be just below the player, like here, and then we make it raycast just a little bit down, like this. Okay, so imagine there's an invisible line that goes from here to here, and if something is between these lines, if we hit something in these lines, like the floor, then it means the player is standing somewhere. If the player is standing somewhere, well, the player is allowed to jump. And then we do that connection between our raycast hit, okay, and our jump access logic. Okay, so when you do this, you basically have all the movement of the player. Okay, we can walk sideways, we can jump, and then we can play the entire game, whatever we have here. Okay, so now that we've done this, we go to File, Save Scene, File, Save Project, and we move on to the next lesson. Now that we have a player that we can walk around and jump, we need to worry about making the camera follow the player, because you can't have a level that's just this long. If the player walks to the right, there's going to be a moment it's going to get out of the player's sight, then, well, it's not going to work correctly. So what we need to do is make our main camera to follow our player. Okay, we need to do a few things here. First of all, since this is a behavior that doesn't exist in Unity, we need to make a script for our camera, for this game object here. So we're going to our project folder, then scripts, and here we're going to make a new one. Right click, create, C# script, and we're going to make a game camera script. It's going to be something quite simple, but we're going to learn how to do a few improvements here and there. Okay, so we select the camera. To make sure this script is going to be executed, we need to add it as a component to the main camera game object. So I'm going to drag the script and drop here in the inspector, making sure that the main camera is selected. Now I'm going to double click the game camera and we need to start coding this. So if you want the game camera to follow something, in our case the player, we need to make sure it's going to have a target. Okay, the target object is the one the camera is going to follow. So let's do a few things here and there and keep improving this camera. Okay, so the easiest step that we can do here, the first thing that we can do here, is to just add a public game object target. Okay, this is different than adding a floating point number. If you save the game camera and you go to Unity, and you wait for the code to be complete, if you look at the game camera component, you're going to see the target field here, but you're going to see that the full value is none. It's not just 0 or empty string, because game objects, they need to be passed as reference. You can't just type in anything here. So what we need to do is we need to grab our player game object and drop it here in the target. Okay, so let's do a few things step by step. If you try to think a little bit, maybe one of your first ideas to solve this problem is to make the camera's position to be the same as the player. Because if I get the camera and I drag it here to the position of the player in the update method, the camera should be following the player at all times. So let's try this solution. I'm going to mono develop here, and in the update method, I'm simply going to type transform.position is going to be target.transform.position. So for every game object we are working with here, we access its component by typing transform, and then we type dot position to get the position field here on top of the transform. Okay, so we should set the values of x, y, and z to be the same. We get whatever is stored in our target position and save it in our game camera position. I'm going to save the script. Let's go to Unity. And we're going to see what's going to happen once we hit play. Okay, I'm going to press the play button. Let's wait for the game to load. And once you press play, notice that everything is blue. So what's the issue here? If you go to the scene window, you see that, well, the camera is actually following the player. If I press the right key, if I jump, the camera will be in the exact same position as the player. But this is the actual issue here. We shouldn't just make the camera be in the same position of the player. If you switch to three-dimensional mode like this, and I move the camera a little bit in front of the player here, you're going to see that the camera is this rectangle, and it's going to render, to draw everything that's within this rectangle. The issue is, if you make the camera to be in the same depth position as the player, in the same Z position, it's not going to render these things. If they were just a little pixel beyond the camera, they would be rendered, but the way it is right now, they won't. They are not inside the visible area of this camera. Okay, so you actually have to think a little bit of 3 dimensions here. Okay, it's like the order things are being rendered. So what we need to do here is to actually use X and Y. We're not going to set Z. If you look at the main camera, by default, its Z position is -10. So it's going to render everything in front of it, including the elements in the Z position 0. So we need to update this. Instead of just setting the position like this one, we're going to use a strategy similar to what we did with the player. This is going to be a new vector 3. Okay, we need to use 3 because the z value is different than 0, so it's important to do this. Okay, now the x position is going to be target dot position dot x. Okay, the y is target dot position, actually target dot transform dot position dot x, target dot transform dot position dot y, and finally transform dot position dot z, because we don't want to change the z position of the camera. So I'm going to save this script now, move to Unity, we're going to wait for the code to be compiled, and after this is complete, we're going to press play. Okay, once we press the play button, our camera is now locked into the player. If you walk to the left and right, you're not going to see a difference, but if you jump, you're going to see that the camera is in fact following the player. Okay, so that's good. We already have movement here, so this is starting to look nice. The thing is, it's strange when this main camera does not have a logic for a smooth movement. Okay, if it's just straight inside the player's position, it's not going to look exactly good. So we need to add a smooth factor to this game camera. Okay, what I'm going to do here in the game camera is add a public float smooth factor. Okay, here, and in the update method, instead of transforming the position like this, we're going to do something a little bit different. Okay, what I'm going to do here is, instead of setting transform.position to be this position here, I'm going to type vector3 target position. Okay, so this object that we're building here is going to be saved in a local variable called target position. And now, for this moment, I'm going to type transform.position is going to be target position. So if you run the game, okay, let me just adjust this. There we go. If you run the game, it's going to behave exactly the same thing. What I want to do is I want to make a smooth transition between this transform.position towards this target position. So what you want to do is to perform a linear interpolation. You're going to go from one value to the other with a certain smoothing factor. So instead of just typing target position here, I'm going to type vector3.lerp. We need to pass the first vector, the first value. That value is transform.position, is the one we are coming from. Now we need to set the value we are going to, which is target position. And finally, we need to pass the smoothing factor. So here I'm going to type smooth factor multiplied by time.delta time. Okay, we need to do this because this is going to take into account if you're running this game on slow and fast devices. The smoothness is going to look more or less the same. Okay, and whenever we run the game, let's make sure that the smooth factor is at least 1. Okay, we're going to make it a little bit greater than 1. So we're going to save the script. Let's go to Unity. We're going to wait for the code to be executed, and in the game camera we're going to add a smooth factor of let's say 5. Okay, for now we're going to use this one. Now let's press the play button. Then we're going to have our player here. If I walk, notice that there is a little bit of smoothness. Okay, if you jump like this, notice that the player is not exactly at the center at all times. I'm going to put my mouse here in the middle of the player. If I jump, the player moves a little bit on the top of the mouse button, of the mouse pointer, and once it falls, it goes a little bit down. Okay, this is a very small adjustment, but it actually adds a lot of good value to your game. Okay, it makes it look much more, much better. Okay, so another issue that we have here, something that we need to improve, is if you run the game like it is right now and you move the player, sometimes you're going to see a little bit of stuttering here. Okay, it's really small. I'm not sure if you're looking this in the video, maybe you are, but you see some stuttering. So this is a common issue when we deal with the camera. The problem that we have here is the way the player moves is we use the rigid body of the player. Okay, if you remember, we use the velocity property of the rigid body. The thing is, physics, they are executed in a separate thread. Okay, imagine you have your game running. You're going to have the update method that runs on every frame, And then you have the fixed update method, okay, which happens in fixed time intervals. This is how the physics simulation works. It's going to work in a fixed time. So if you just use the update method, sometimes the camera is going to be updated faster than the physics, and that's why we're going to see a little bit of stuttering. So what we need to do here is, instead of use the update method in the game camera, we're going to use fixed update, because that's going to take the physics simulation into account, okay, and it's going to eliminate this stuttering. If you press play at this moment after you save your script and go to Unity, if you move the player, then you're going to see that it feels like the camera stopped, but actually we are moving. If I release the arrow key, the camera goes back to the center, okay? This is happening because it's completely smooth now, okay? It's following the player at the same thread. This is very important information, okay? I'm going to put here fixed update is called on a fixed time interval. Okay, for example, it's just changing this comment here. So we need to use the fixed update to make sure we're going to see no stuttering at all here. Okay, so a few more things. Whenever you play a platformer game, your camera doesn't center at the player like it is right now. Okay, at this moment, the camera is exactly at the center of the player. What we normally have is a little bit of offset. Instead of making the camera in this exact position, we offset it a little bit to the top and to the right. And this is actually something pretty simple to do. We're going to the player, to the game camera actually, here. And we have the target, we have the smooth factor, okay? And I'm going to add here a public vector3 offset. Okay, and this offset, we're just going to add it here in target position. Before every of these lines, I'm going to add its correspondent axis. So offset.x plus the position, offset.y plus that position, and offset.z plus the final position, the depth position. If you do this, if you save this, and you go to Unity, and you wait for the game to be complete, for the code to be compiled. If you press play, okay, we're going to run the game now. No offset is being applied, but if you change it while the game is running, you can find some good values here. So x is set to 0. If you change it to 1, it's going to look like this. 2 and 3, and you're going to find a value that's looking good. If you want to fine-tune this value, you can drag the x around. Okay, like this. Just click on the X label and you can change it like this. I'm going to leave it on 3. As for Y, let's use 2. 2 sounds like a good one. And as you play the game, it's going to look like this. Okay, I think it's pretty fine. 3 and 2 on Y. So we're going to stop the game, save these values here, 3 on X and 2 on Y. We can save the scene if you want and press play to see the same thing as we were looking at right now. And we can add one more thing, one final thing. We can set the minimum position for the main camera, okay? And actually the minimum position for the height, for the Y value of the position. Because if the floor is just this high, we don't need to show what's below the floor, okay? If the player just falls from this height, well, it's basically going to be game over. So we can set the minimum position, the minimum vertical position for the camera. So we're going to the game camera here. I'm going to add a public float minimum Y. Okay, this is something that we are going to set in Unity. And to make sure that the minimum Y is going to be respected here in the target position, we're going to transform this a little bit. I'm going to call mathf to call, like the summary says here, a collection of math functions. This is very good for us. Then dot max, okay, I'm going to explain to you why soon. mathf.max, and it receives 2 parameters. This is the first one, and the final one is minimum Y. Okay, so a question here. If we are talking about using a minimum value, why are we using the max value? Okay, it's a bit tricky, it doesn't make much sense at first, but remember, this is going to be a positive value if the player is moving up. So if the minimum value for Y is 0, for example, if the camera is in the position 1 or 2 or 3, the result, the outcome of this method call is going to be 1, 2, or 3. But if this value here, if the camera is trying to move to a negative value, the maximum value of this method call is going to be minimum y. So essentially, we are forcing for the minimum value of the vertical position to be minimum y by using the max value, okay, the max method call. So we're going to save this. Let's go to Unity. We're going to wait for the code to be ready. Let's look at the values here at the game camera. I'm going to leave it on 0 because it's how it's working right now in the scene. If you press play and look at how the game is being executed, the player is here. If you jump, the camera rises a little bit, okay, but once the player is down, the camera doesn't go past this point. If you were to change the vertical offset here to a number that's very low, okay, like -17, minimum y is not going to allow the camera to be under a value lesser than 0. If you change this to something negative, then yeah, it would allow. But if you use minimum y set to 0, it's going to force the camera's position to be this one. Never goes beyond that, even if you use -1000 here on y, okay? So it's not going to change. But if you leave it at 3 and 2, it's going to look pretty well. Okay, you can jump, the camera moves up, but you can still see the floor like this. Okay, if you want, you can change this a little bit more, so you can see the camera, the player here on the floor, or maybe use 1. Okay, so the camera just rises a little bit, so you don't lose track of what's below you. Okay, so let's use this 3 1 0 0 5. Okay, so stop 3 1 0 0 5. So looking good. Okay, so notice that we took a lot of time just explaining how to make the camera follow the player, but it's very important to understand step by step. Okay, I assure you that this is going to be very, very easy for you to implement in your future games because you actually understand how all of these steps work. Okay, if you see things, if you learn things step by step, you're going to learn, and it's going to be pretty easy. It's going to be natural for you to implement this in your future games. Okay, so let's make sure all scripts are saved. We're going to save in Unity here, save scene, save project, and we're going to move on to the next video.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.